Hello everyone, I am Rahul sir, your management educator. A warm welcome to Global Online Platform. Today I am here with a full syllabus crash course on our unit number 8, that is Statistics and Operations Management. Here a full syllabus of this unit is covered in a one video. Here we have targeted all the 100% sure topics which are asked in the exam. So watch this video completely. You will be able to answer all the questions asked in this unit accurately. Before starting, there is an important information for you that we are offering the UGC Paper 2 Management for the UGC NET 2022 exam. As you know that the exam is very close. So if you take the management course, you will get complete video lectures, full syllabus notes, full syllabus based mock test through MCQs, and complete paper 1 totally free. For this, you have to download our global online app and you can contact on the given number to join the batch. What you have to do, you have to just visit the Play Store. From where there you have to download our official global online app, and after downloading and login, you will see the home interface. In this home interface, you have to click on the store button, and you will, after scrolling, you will get the UGC NET Paper 2 Management course, or if you have another option that you can search just by typing UGC NET Paper 2 Management in the search box also. After the payment, you can access the content which we have provided in this course in number of times. So let's start from what is statistics. Of applied mathematics that involves the collection, description, analysis, and inference of the conclusion from the quantitative data. Remember this point, it can be asked, statistics deals with both qualitative and quantitative data. No, statistics is basically concerned with the quantitative data only. It is the branch of applied mathematics which involves the collection, description, analysis, and inference. TDAI, collection, description, analysis, and inference it deals with. Okay, I hope this definition is clear. Now we have two types of statistics. One is descriptive statistics and one is inferential statistics. Descriptive means what? You are just describing the things, and in inference you are finding out the conclusion. Descriptive statistics involves the organizing, summarizing, simplification, and describing the describe and present the data. But in case of inferential statistics, there will be generalization from the samples to the population. A generalization will be made from the samples to the population. Here it involves the hypothesis testing and predictions will be made. So inferential statistics involve the hypothesis testing sorry, the making predictions and generalizing the samples to population. I hope this is clear. Now we are starting with the important topic, that is measures of central tendency. Here in this measures of central tendency, the central tendency is stated as the statistical measure that represents the single value of the entire distribution. An entire distribution is there and a single value is representing it. It is called as mainly the central tendency or of the data set. Okay, it aims at to provide an accurate description of the entire data in the distribution. Whatever the data exists in the distribution, only a one single value can will try to give us the accurate description. This is called central tendency. Now, central tendency is further classified, or average. Central tendency is also called as average. So the average will be classified into two groups. Means one is will be the mathematical average, where mathematical operations will be used to calculate the average, and another is positional average, which is related to position of the average. Then here in case of mathematical average, we have the mean, which is of mainly three types: AGH, arithmetic mean, geometric mean, and harmonic mean. But in case of positional average, we have we have two things, that is median and mode. Median is the central value and mode is the most fashionable value. Let's understand what are the measures of central tendency? The measures of central tendency, I hope I have told you, shown in you in the chart. So here one by one we are discussing. First one is the arithmetic mean. Arithmetic mean or AM is the called the average. It is just the ratio of sum of all observations to the total number of observations. It is the sum of the observation or to the number of observation. You are just calculating the average. Suppose I was showing you. Suppose here four numbers are given 2, 6, 8, 10, 9. So here you what you will do, you just 16, it's 16, 26 and 9, 35 and 35 divided by 5, that is 7 will be the center will be the mean. Okay, this is sum of the entire numbers divided by number of observation. Just like when we normally calculate the average, it is like that. Then the median is the middle number in the sorted ascending or descending list of the numbers that can be more descriptive in the more descriptive of the data set than the average. What does median do? Median, for calculating the median, you have to arrange the data in either ascending or descending order in a sorted form. Then you will be able to find out the middle number which is representing the whole series. It is median is a positional average. Okay. It describes the data in a descriptive way. Okay. Then we have mode. The mode is the value that appears most frequently in the data set. A set of data may have one mode, more than one mode, or no mode. Okay, then mode is just what it is also called as most fashionable value. Whenever you are studying in college or in school, there was a group which was frequently roaming here and there to gain all the information. So this is like that. The value which is frequently repeating in a data set, it will be called as mode. So mode will be mode will be the most frequent value. Okay, then a distribution can have either one mode or one greater than one mode, or no mode will be there. If whenever the mode is not able to represent the data set, it is called as ill mode. Okay, then we have the another two mathematical average, that is geometric mean and harmonic mean. The geometric mean is the average value or the mean which signifies the central tendency of the data numbers by finding the product of their values. Basically, we multiply the numbers all together and take the nth root of the multiplied numbers, where the n is the total number of the data values. Here what the same thing which have seen in the form of mean, we are doing the same thing, but what we are doing, we are finding the average by using the root sign, and the whatever the total number of observations are there, we will take the nth root. N is the total number of observation, and we will product all the numbers which are available in the data set. Okay, I hope this is the geometric mean. Then we have harmonic mean. Harmonic mean is defined as the reciprocal of the average of the reciprocals of the data value. Here the the data values will be we will do the reciprocal of the data values and find the reciprocal average. Okay, it is the mean which gives less weightage to the large value. It is the mean which gives less weightage to large values and large weightage to small values. Here the small values are given greater weightage than larger values. Okay, to balance the values correctly in general, so that the proper balance can be maintained between the values in a data set. Okay, in general, the harmonic mean is used when there is a necessity to greater weight to the smaller items. When the greater weightage is required for the smaller terms, we will use the harmonic mean. It is applied in case of times of average rates. It is used in case of times and average rates. Okay, one is also there, that is weighted means. in case of weighted means we use the weights. Weights are assigned to different observation and to find that mean. Then here we are starting with the properties of different measures of central tendency. This part is very much important from exam point of view, because this these properties become the base for statement wise question to find out the either correct or incorrect statement. Okay, these are the properties of arithmetic mean. Here we are discussing properties of arithmetic mean. The first one, a constant b is added or subtracted from every observation. The mean of this observation will also get added or subtracted. Here what it is talking about, it's just talking about mean will be affected by scale. Mainly there are two things. Sorry, it was origin. Mainly generally two things are there. One is origin and one is scale. Mostly people confuse among this, so I am telling in detail. So what does origin means? Origin means whatever you are adding and subtracting, and scale means the whatever the multiplication and division you are doing with the observation, it will be called as scale. So if you add or subtract to the arithmetic to any number in the data set, the whole mean will be affected. And if you on the other hand, if you will multiply or divide by any divide any of the observation in the data set, the whole value will be, the actual value of the mean will be affected. Why? Because mean is mean is dependent of scale and mean is dependent of origin. Okay, it is dependent of both scale and origin. Now let's see the second one. If every observation is multiplied or divided by the constant beta, the mean of this observation will also get multiplied and divided. It is same talking about that mean will be affected by both scale and origin. Okay. Then the sum of deviations from the observation from the arithmetic mean is always 0. Remember this point. The sum of the deviations from the observations from the arithmetic mean is always 0. Then the sum of the squared deviations of the observations from the arithmetic mean is minimum. The sum of the squared deviations of the observation from the arithmetic mean is minimum. Then third, the last point is arithmetic mean is capable of being treated as algebraically. Arithmetic mean can be algebraically treated. Okay. I hope you might have understood the properties of the arithmetic mean. Now let's discuss the properties of geometric mean. Geometric mean we have seen where we use the root values to find out the mean. Okay, the geometric mean for a given data set is always less than the arithmetic mean for the data set. Remember this point, that the GM will be less than the AM. Okay, geometric mean will be always be less than the arithmetic mean. Okay. Then if each object of the data set is substituted by GM, then the product of the objects remains unchanged. If each data set is substituted by using the geometric mean, the whole it will remain constant. Okay. Then the ratio of the corresponding observations, just a second. The ratio of the corresponding observations of the geometric mean of two series is equal to the ratio of the two geometric mean. Whenever we take the ratio of two corresponding observation in geometric mean, it will be equal to the ratio of their geometric means. Okay. Then the products of the corresponding items in the geometric mean in two different series will be equal to the product of their geometric mean. Okay. It's just talking about the scale and origin. If two different series, then if the observations will be multiplied together, then it will be similar to the multiplication of geometric means of those two series. Now here are the for all the three formulas, that is arithmetic mean, geometric mean and harmonic mean. Here arithmetic mean is just adding the values and divided by total number of observation. In case of geometric mean, you will find the root, that is under root 3 a into b into c. Okay. Then in case of harmonic mean, you will just keep the number of observation in the numerator, and reciprocal the number will be done. The reciprocal of the actual observation will be done, that is 1 upon a 1 plus 1 upon b plus 1 upon c. So these were the formula. Now let's understand the properties of median. Median, we have seen that after ascending and descending order, after arranging the value in ascending or descending order, whatever the value we get, it is called as the median. It represents the center of the data set. So whenever the value which is representing the center of the data set in a proper in a sequence, when it is arranged in either ascending or descending, it is called as median. Okay. Now let's see the properties of median. Outliers and skewed data have less impact on the median. Outliers and skewed data have will not have that much impact on the median. Then if the distribution is skewed, the median is a better measurement as compared to mean. Whenever a skewness exists in the data set, means skewness basically means when the mean, mode and median are not equal, a bell-shaped curve is not formed. We will study further, don't worry. Then we have the median is best measure as compared to mean. Then median is not dependent on the dataset value of the dataset. Median is not dependent on all the values of dataset. Then fourth one is the median. The median value is fixed by its position and is not reflected by the individual value. Each individual value will not reflect the median. It will the median value will be fixed by its position only. Okay. The distance between the median and the rest of the values is less than the distance from the any other point. The distance between the median and the rest of the value is less than the distance from any number of points. Okay. Then every array has a single median. Every array means every data set will have only one median. Then median cannot be manipulated algebraically. It cannot be weighted or combined. There will be no weights cannot be assigned to medians, or they cannot be combined. That's why and no algebraic treatment can be done over the median. So it is positional average. Okay. Why? These are the main reason behind this behind the not doing the algebraic treatment is because median is the positional average, not an algebraical method. Okay. Sorry, not a mathematical average. Then in a grouping procedure, the median is stable. Median is stable in case of grouping group data. Then median is not applicable to qualitative data. Median is already used to find out the in case of quantitative data. It will not be applied to qualitative data. Okay. Then the values must be grouped and ordered for computation. For computing the median, the groups and the observation should be arranged in a particular order. Then median can be determined for the ratio, interval, and ordinal scale. The median cannot be except the categorical scales. Except the median can only be determined for the ratio, interval, and ordinal scale. Okay. Basically, it will starts from the ordinal scale only, where the data is arranged in a particular order. Now let's see the properties of mode. The mode is not unduly affected by extreme values. Mode is not unduly affected by extreme values. Then the mode is not calculated all over the observation of the dataset. The mode is not calculated on all the observations of the dataset, because what we will just pick up the value which is frequently repeating in the dataset. Okay. Then the third point is the value of the mode can be computed graphically, whereas the value of the mean cannot be calculated graphically. Graphically, value of mean can't be represented, but by by using the histogram, you can represent. You can find out the value of mode graphically. Okay. Then The value of the mode can be calculated in open distribution without knowing the class limits. Without knowing the class limits, mode can be calculated from the open-ended distribution. Okay, but then we have the mode can be conveniently found even if the frequency distribution has class interval of unequal magnitude, provided then the modal class and then the class succeeding and preceding are of same magnitude. Means what it is trying to say, suppose if there is any class here that is 10 to 12, 10 to 19, 20 to 21, in this case also you don't need to arrange this in close-ended frequencies. Here also you can, using the open interval data, you can determine the mode. Okay. Then the last one is, sometimes it may not be possible to calculate the mode. Sometimes mode is difficult to calculate because it if the data set has a bimodal distribution, if the data set has bimodal means what? Two modes will there, in which there is a two possible values for the mode. There can be two possible values for the mode. Now let's see the formula of the median. Median is what? Median, in case if the value number of observations are odd in number, then what you will do? You will just put the n plus 1 divided by 2. Okay, this will be done in case of n plus 1 divided by 2 will be done in case of median only. Then but in case of if there are even numbers of observation, when there are even numbers of observation, you will just do that x n plus 1 n divided by 2 will be one set, and n divided by 2 plus 1 set. Both will be added together to find the median in case of even terms. Okay, I hope. And whole the sum, and the sum will be also divided by 2. Okay, it can be either multiplied by 2, or the both of the summation of this n by 2 and n plus 1 by 2 can be divided by 2 to find out the median in case of even number of observations. Now, when there is a group frequency table, when there is a group frequency class interval type table is there, how at that time how mean can be how mode can be computed, then here we will use this formula, that is L1 plus n by 2 in the whole bracket, n by 2 minus CF. In the denominator, we will divide it by the frequency and multiplied by h. It is the length of the class interval, means that 10 raised to 20 is the class interval. The h will be 10. Okay, the difference between these two values will be the h. Okay. Then L is the lower limit of the median class. Whatever the median class will be chosen, L will be the lower limit of the median class. Then N will be the number of observations. CF will be the cumulative frequency of the class preceding the median class. This point you should remember, that cumulative of not succeeding class will be taken, the preceding class will be taken. Okay, F is the frequency of the median class, and H is the class size. That is just I had shown you, if the 10 to 20 is the median class, the H will be difference between the two upper limit and the lower limit. It will be called as H. Okay, class size will be there. Now, in case of mode, we have seen the formula of all the three formulas in case of median. Now we will discuss the formula of mode. In case of mode, you can use this formula, is quite lengthier, that L1 plus F1 minus F0 divided by 2 F1 minus 2 F1 minus F0 minus F2 into H. Okay, this is the way you can compute the mode in case of grouped frequency table, where L1 is the lower limit of the modal class. Here modal class, earlier we were considering, in case of median we were considering the median class, here we are considering the modal class. L is equal to lower limit of the modal class. H is the size of the class interval, assuming that all the class sizes to be equal. Then F1 is the frequency of the modal class. F0 is the frequency of the class preceding to the modal class. F0 means what? It is 0. It is 0 is 0 comes before 1. So it will represent the frequency of the preceding class will be taken, and F1 will be frequency of that modal class, and F2 will be what? Frequency of the class succeeding to the modal class. Suppose here 10 to 20 is your modal class. Then what you will do here, you will take the 0 to 10, you will take as a F. This will be your F1, this will be your F0, and this 20 to 30, this will be your what? This will be your F2. Okay, I hope this is clear. And H is again the class size. Now we study the empirical relationships among the mean, mode, and median. In case of mean, mode, median, there is an empirical relationship exists. Here, the formula for this empirical relationship is the mean minus mode is equal to 3 mean minus median, or it can be also calculated by mode is equal to 3 median minus 2 mean. Okay, I am repeating this once again, that mean minus mode is equal to 3 mean, 3 whole bracket mean minus median, or mode is equal to 3 median minus 2 mean. So that was all about your central tendency measures. We have covered everything in detail. So now we are starting with the measures of dispersion. Then let's understand what is dispersion. Dispersion is a state of getting dispersed or spread. Statistical dispersion means that the extent to which the numerical data is likely to vary about an average value. In other words, dispersion helps to understand the distribution of the data. Dispersion simply means that whatever the scatteredness, whatever the variations are there, how far the value is from the center value, it is called as dispersion. Okay. Now we have different measures of dispersion. These are categorized under 2 parts. Like measures of central tendency was classified in 2 parts, like positional average and one was mathematical average. These were the 2 classification in 2 categories in central tendency. Now here absolute measures are there and relative measures are there. So in absolute measure we have RQMS. RQMS means range, quartile deviation, mean deviation, mean or absolute deviation, and standard deviation. These 4 are the absolute measures. But here when you will add the word coefficient, it will become a relative measure. So the coefficient of variation, coefficient of quartile deviation, then coefficient of mean deviation and standard deviation. These are the 4 relative measures of quartile dispersion. Okay. Now this is the most comprehensive chart. Here you can see all the sort of formulas are given related to all the absolute measure and relative measure. Let's discuss one by one. I am discussing in advance so that you can get quick glimpse. When we discuss the concept, there also I have added us one slide. So range is what? Largest minus smallest value, the most simplest one. Quartile deviation is QD is equal to Q3 minus Q1 upon 2. Then we have mean deviation. MD is equal to summation F1 whole bracket X1 minus X bar bracket close divided by summation Fi, means sum of total observation. Then standard deviation. SD is denoted by sigma. Here under root we have F1 into X1 minus X bar whole square divided by N. Then we have variance. Variance is what? Sigma square. Sigma square M is equal to summation F1 X minus X bar square divided by summation Fi. Then if we talk about the relative measures, here all these were we discussed are absolute measures. Now we will deal with the relative measures. For coefficient of range, you just have to largest minus smallest divided by largest plus smallest. Then in case of quartile deviation, we have Q3 minus Q1 divided by Q3 plus Q1. Then coefficient of mean deviation, MD divided by median. Then coefficient of SD divided by mean into is equal to sigma divided by X bar. This is represented symbolically in here. Here it is represented symbolically, and here it's in words it is mentioned. Okay. Then coefficient of variance, CV is sigma upon X bar into 100, means standard deviation upon mean into 100. So I hope a quick revision of formula is done here. Now we start one by one. the range is the simplest quantity that can be used to measure the degree of dispersion spread in the given data values. It is defined as the difference between the largest and the smallest value in the given data set. In the given data set, whatever the difference is between the largest value and the smallest value, it is termed as range. Okay. Then we have some properties of range. What are these properties? Let's understand one by one. So range is what? The values of range is always non-negative. Range cannot be negative. It will be always positive. Okay. Then the value of the range equals to 0 if and only if the given set of data cells are all equal to each other. Each other means all the values are identical in the data set, then only the range will be 0. Suppose you have to calculate this range 3, 3, 3, 3, 3, or this type of data you have, you can the range will be, value of the range will be 0. But in case here you have 3, 7, 8, 9, 10. So here you can easily determine largest minus smallest, that is 7 is your range. Okay, I hope this is clear. This point is because most of the time in statistics, properties and formulas, these are only the two things, or sometimes assumptions. In case of hypothesis testing, assumptions are the made base, or correlation in such topics, the assumptions are made for base for the questions. Only AF means assumptions, formulas and properties are made base for the question. Okay, then point number 3, if the range is non-zero, we can conclude that the given data values are not all equal to each other. Means if the range is any number regarding except the negative or 0, the values will be different. They will not be identical. Okay. The fourth one, for the continuous frequency distribution, we can find the range by subtracting the lowest limit of the smallest class from the upper limit of the highest class. You can just find the range by subtracting the lower limit of the smallest class and upper limit of the highest class. Okay, then point 5 is what is the fifth one, that when finding the range from the frequency distribution, we do not consider the frequencies of the classes. While calculating the range, we don't consider the frequencies of the class, only the upper limits and lower limits of the respective highest and the smallest classes are considered. Okay, then the sixth one is the value of the range is independent of change of origin. The value of the this point is important because these types of statements become base for statement wise question. The value of the range is independent of change in origin, means there will be no impact of any addition or subtraction in the dataset on range. Then we have range formula. The formula of the range is maximum value minus minimum value. Range is what just we have seen, largest minus smallest value. Then how to determine the coefficient of range? It is simply L minus S divided by L plus L. So that was all about your range. I hope you understood. We are running fast because it's a crash course and we have to cover n number of things. I hope you are understanding. The mean deviation is defined as the statistical measure that is used to calculate the average deviation from the mean value of the given data set. Here, what we are doing, mean deviation means what? Here we are calculating the dispersion through, or the deviations in the value through by using the mean. Mean deviation is also called as average deviation. Okay, because we are calculating it from the mean. So it is also called as average deviation. The mean deviation is the data values can easily be calculated using the below procedure. Here, what we will do, first we will find the actual data average and then we will find the deviation. Okay, then let's understand the properties of mean deviation. The mean deviation values, its minimum value when the deviations are taken from the median. The value of the mean deviation will be minimum when it are taken from the median. Okay, then the mean deviation remains unchanged due to the change in origin, but changes same due to the change in scale. Means it simply means that there will be no impact of any addition or subtraction on the mean deviation, but it will be affected by change in any sort of multiplication or division. Okay, then if the y is equal to a plus bx and a and b are constants. Okay, constants. Then the MD of y is b into MD of x. Okay. Then third one is it is rigidly defined. Mean deviation is rigidly defined. Fourth point is it is based on all observations and not much affected by sampling fluctuations. If any sort of sampling fluctuation is happening, it will not impact the mean deviation to large extent. Okay. Then we have point 5, that is it's difficult to comprehend its computation. The computation of means, it's quite difficult to comprehend. Okay. Then point 6 is furthermore, unlike standard deviation, mean deviation does not possess mathematical properties. The mean deviation does not possess such mathematical properties like standard deviation, because generally what we eliminate the signs. Here this sign is basically used, x minus x bar. This is what? This the negative sign will be converted to positive here. So the signs will not be considered. That was the biggest drawback of mean deviation, for which the standard deviation was came to overcome this weakness. Here, let's see the formula of mean deviation for ungrouped data. We have about mean. If you want to calculate the mean deviation about mean, you will just see the x1 minus mean divided by n. Okay. Then for about median, if you want to calculate, then x minus median, summation of x minus median divided by n. Okay. Then if you have the group data, when you have having the group data, what you will do, summation f1 x1 minus mean, signs will not be considered, divided by summation f1, divided by frequency, summation of frequency will be in case of mean. Then if you want to calculate from median, in case of while calculating from median, r is equal to 1 and summation f bracket x1 minus median divided by summation f1. I hope these formulas are clear. I will suggest you to just write the formulas whenever it is coming, so that it will be helpful for you to recall at the last minute. Now, let's see. I failed to give the heading, sorry. Here we are discussing the quartile deviation. Mean deviation is over. Now we are discussing the quartile deviation. The quartile deviation can be defined as a mathematically as half of the difference between the upper and lower quartile. Upper quartile, the difference between half of the upper quartile and lower quartile is called as quartile deviation. Okay. Here the quartile deviation is a representation of QD. Q3 denotes the upper quartile and Q1 denotes the lower quartile. Okay. Q3 will denote the upper quartile, because 3 is what? 3 is big number. So it will denote the upper quartile. But Q1 is what? Q1 is lower, smaller number. So it will represent the lower quartile. I am telling this because sometimes many people fail to understand what is which Q is either Q1 is upper quartile or Q3 is upper quartile. They may get confused. That's why I am telling you this trick to remember that Q3 is bigger number, so it will be upper quartile, and Q1 is smaller number. 1 is smaller number, so it will be lower quartile. Okay. Then quartile deviation is also known as semi-interquartile range. Quartile deviation will also known as semi-interquartile range. Then quartile deviation formula. Suppose Q1 is the lower quartile, Q2 is the median. Q2 is also median. What is the, in terms of quartile deviation, the value of Q2 will be called as median. Okay. And Q3 is the upper quartile for the given data set. For the given data set, Q3 is the upper quartile. Then its quartile deviation of formula is simply mentioned here, Q3 minus Q1 divided by 2. Okay. This is the formula of quartile deviation, Q3 minus Q1 divided by 2. Let's see here the quartile deviation formula is more expressed in elaborative way. Q3 minus Q1 divided by 2. Then how to determine the coefficient of quartile deviation. Coefficient of the quartile deviation can be is calculated by Q3 minus Q1 divided by Q3 plus Q1. Then we have lower quartile, Q1 is equal to n plus 1 into 1 by 4. N by 1 by 4, when you will do, it will give you the value of lower quartile. Then to find out the middle quartile, you just have to n plus 1 divided by 2 by 4. Okay. Or it simply means to find out this n plus 1 divided by 4, because this will what? This will be 1 by 2. So n plus 1 divided by 2, middle quartile, it is median. Q2 will be will be called as median. Okay. Let me write. This will be the value of median. Then we have upper quartile. Upper quartile Q3, it will be calculated as n plus 1 into 3 by 4. Okay. So these are, this was all about quartile deviation. Let's come to standard deviation. Now we are discussing the standard deviation. Standard deviation was given by Carl Pearson. He may be using Pierce soap. That's why he's known as his name is Carl Pearson. Okay. Jokes apart, because now let's understand standard deviation. It was coined by Carl Pearson, and it is also called as root mean square deviation. Because why? Because we are using root sign to calculate the standard deviation. So it is also called as root mean square deviation. Then a standard deviation is denoted by sigma. Remember this sign, sigma is used to denote the value of standard deviation. Then it's a measure of how dispersed data in relation to the mean. Low standard deviation means how the value of how far is the value from the mean, told by the standard deviation. Then low standard deviation means the data are clustered around the mean. When the values are close towards the mean, it will be the value of standard deviation will be low. Okay, and when the value of standard deviation will be high, the data is more spread out. The value is away from the mean. When the values are away from the mean, then the value of standard deviation will be less. Okay, when the other data is away from the mean, spread out will be there. It will be denoted by the greater value of standard deviation. I hope this is clear. Another name for standard deviation is root mean square deviation, and it was coined by Carl Pearson. So let's understand the properties. Properties, it cannot be negative. Standard deviation can't be negative because their dispersion always exists. Then it is only used to measure the spread or dispersion around the mean of the data set. In case of mean deviation, we were using median and mean to calculate the mean deviation, but to find out the dispersion or scatteredness. But here, or spread. But here, in case of standard deviation, only mean will be used to find out the spread or dispersion. Okay. It shows how much variation or dispersion exists from the average value. How much dispersion exists from the standard average value, it will be told by standard deviation. Then it is sensitive to outlier. Standard deviation is affected by extreme values. A single outlier can raise and in turn distort the picture of spread. Okay, means outlier means what? Extreme values. Then point 5, fifth one is for data with almost the same mean. If a data set where the mean is same, the greater the spread, the greater the standard deviation. Where almost the same mean is there, the greater, if the spread is greater, the value will be the value of standard deviation will be greater. Then point 6, we have standard deviation can be used in conjunction with the mean in order to calculate the data intervals when the analysis normally distributed data. When the normal distribution, when the data is normally distributed and it is analyzed. So in case of mean, in order to calculate the intervals, in case of interval based data, we use standard deviation to conduct the dispersion. Now, here is the formula of standard deviation, that is sigma is equal to under root mean minus summation of x minus mean square divided by n. Okay. Then here x is the set of numbers, then mean is the average of the set of numbers, then n is the size of the set, means summation of the frequencies, and sigma is the standard deviation. Okay. So I hope this formula is clear. Then this is the quartile division formula again. Q3 minus Q1 divided by 2. I will suggest you, let me go back. To take the screenshot, you should take the screenshot of this slide, because here all the formula are given in a crispy way, and it will help you to memorize by simply watching the simply studying the screenshot twice, thrice. You will be able to recall all the formula in exam. Let's understand what is variance. The term variance refers to the statistical measure of the spread between the numbers in a data set. What is the statistical measure? Is again checks the spread. Okay, most specifically, variance measure how far each number in the set is from the mean, and thus form the very other number in the same set. Means whatever the it's again saying the same thing, that it specifically measures how far is the mean is the numbers are there from the mean. Okay, from the every other number. Variance is often depicted by the symbol of sigma square. Okay, sigma square, and the sign sigma square is used to as a symbol of median. Okay, just a second. This is the sign for this representing the variance. Okay, it is used by both analysts and traders. It is used by both analysts and traders to determine the volatility and market security. As when we were discussing the our CAPM model, there we have seen that sigma sign was there. But here is what that was only the standard deviation. What it was representing? It was representing the systematic risk. Okay, so here the analysts and traders both use this variance. Okay, then the square root of variance is the standard deviation. When we take the under root of variance, it will give you the standard deviation, which helps to determine the consistency of in investments returns over the period of time. The standard deviation tells the consistency, how consistent return you will get over a period of time. Okay, so that's all about the variance. Here is the formula. Variance square is equal to summation f1 into x1 minus x bar whole square divided by summation f1, and the coefficient of variance divided by sigma divided by x bar, means SD divided by mean into 100. Now we have skewness. Their measurements of skewness. Skewness means what? When the value of mean, median and mode are not equal. When both are not equal, there are some when these three values are not equal, mean, mode, median, in case of a normal distribution curve, then there exists some skewness. Then measures of skewness is used to determine the difference between the mean, median and mode in distribution. The following table can summarize it. So let's understand from here. Mean minus mode. If the difference between mean, median, mean minus mode is greater than 0, that is, if it is positive, then the distribution is skewed to the right or positively skewed. When the mean minus mode difference is greater than 0, there will be the NDC will be rightward skewed, or it will be positive skewed. When mean minus median is less than 0, then the NDC will be, NDC means the normally distribution curve will be skewed to the left, and it will be called as negatively skewed. And if the mean minus median mode is equal to 0, it will be symmetrical, that the distribution will be symmetrical. Here any sort of skewness will not exist. Now let's understand one by one. So here indicates the positive skewness, where when it is skewed to the right, then this is the best one, where all the three values of x, m, z are equal. X is equal to M equal to Z. X is the mean, M is the median, and Z is the mode. Okay. This is the symmetrical distribution is the representative of binomial. Not binomial. It's the representation of normal distribution curve. Okay. Then when the distribution is negatively skewed, it will be skewed towards the left. I hope we have done dispersion. Now we are starting with the correlation and regression. Okay. So what is correlation? Let's understand. Correlation simply means that there should be an study of an association between a variable, where either how much the variables are interrelated. It is mainly study in correlation. Okay. Then correlation is a statistical measure that expresses the extent to which the two variables are linearly related, measuring their change together at a constant rate. Because what it is called that it checks that whether any sort of relation exists between the two variable or not, whether this relation should be in a linear way. Okay. It's a common tool for describing the simple relationships without making statement about the cause and effect. Regression deals with the cause and effect, but correlation just checks that whether any sort of relationship exists between the two variables. Okay, it can be the variables can be two or more. We will study this in the types of correlation. Now let's see what are the different uses of correlation. So first one is it is used in driving precisely the degree and direction of the relationship between the variables like price and demand. In economics, whenever we study the law of demand, we see that whenever the price will decrease, the demand will be greater and vice versa. Okay. Then advertising expenditure and sales and rainfalls and crop yield, etc. These are the examples of correlation. Okay. Then it is used in developing the concept of regression. Before studying the regression concept, it is necessary to understand the correlation. So whenever there is a correlation among the variables, then only we can say that there is a chance of cause and effect relationship. That is regression. The ratio of variations which help to estimate the values of one variable for the another, the given value of the another variable. So this is written about the regression. Then third is it is used in reducing the range of uncertainty in the matter of prediction. Correlation helps in reducing the range of uncertainty. Okay, then it is used in presenting the average relationship between the two variables through single value coefficient of correlation. The coefficient of correlation is generally used to present the average relationship between any two variables. Okay. Then last point is there. In field of economics, it's used understanding the economic behavior and locating the important variables on which others depend. In economics, there is important to understand the consumer behavior to find certain factors by understanding the relation between different variables which impact the behavior in of a customer's behavior in economics in terms of economics. So it is very much important that there should be a correlation existing among them. Now let's see what are the types of correlation. What are the types of correlation we are studying? That correlation basically here is the chart which is classifying in three categories on the basis of degree of correlation. What's the degree of correlation? Here PN exists means positive and negative correlation. On the basis of number of variables, there is three type of correlation. SPM means simple, partial and multiple correlation. And on the linearity, on the basis of linearity, there exists only LN correlation. This is not that LN institution, it is L and N only. Then that which means what? Linear and non-linear. So this classification is important. These types are important because it can be asked in match the column type questions. Okay. Let's understand one by one. First one is positive correlation. When the variables are moving in the same direction, it's positive correlation. When the variables are moving in the same direction, it will be termed as positive correlation. Then we have negative correlation. When the variables are moving among the opposite direction in a negative is negative correlation. Then when the simple correlation, these two were according to direction. This earlier, this first and second was according to direction. Now this third, fourth, fifth are according to the number of variables. Simple correlation is a relation studied among two variables. When the relation is just studied between the two variables like price and quantity demanded, it is called as simple correlation. Then the partial correlation, when the three variables are taken and the relation is studied among the two variables, assuming the other is constant. Okay, let me tell you an example for this. The partial correlation means what? Whenever you study between the relation, you will take three variables. Three variables will you take, and one variable among them will be constant, and here only the two variables will be studied. So for example, in a family, here mother is there and father is there and their child is there. Okay, so we are studying this. This is an example of partial correlation. Why? Because this variable, that variable child is being constant, and suppose anything issue happens, the relation is checked after that issue. The relation will be checked among this mother and father. So that will be called as partial correlation. Because why? There the child who is one of the variable, it's kept constant. So this was the partial correlation. I hope that example was jokes apart, but you will remember this. Then multiple correlation, when the relation is studied among three or more variables. Suppose what now the pre-monsoon has started. So whatever, how much rain is fallen, and what was the amount of thundering and lightning and rainfall. These are the three different variables. When you are trying to study, relate to find any association between this variable, here number of variables will be more, so it will be called as multiple correlation. Then we have linear and non-linear correlation. Linear correlation is what? When all the points on the scatter diagram tend to be near to the line, which looks like a straight line, the correlation is said to be linear. When on all the points are in a straight line format, that will be called as linear correlation. Non-linear correlation means when all the points in the scatter diagram tend to be near a smooth curve. When the smooth curve will be there, it is called as non-linear correlation. This diagram will help you to understand that when this diagram here, on one line all points are existing nearby to it, it will be called as linear, and here a curve will be there. It will be a non-linear correlation. Non-linear correlation is also known as curvilinear correlation. Now let's try to understand different methods of correlation. Different methods of correlation are there. Let's try to understand them. So in this methods of correlation, we have scatter diagram method, Karl-Pearson methods. अरे ये कहाँ से आ गया? Okay, let it be. I am telling you, don't worry. So there will be four methods are generally used. That is scatter diagram, Karl-Pearson coefficient of correlation, then Spearman rank correlation, and method of least square. These are the four methods studied to find out the correlation. Okay. So scatter diagram means, let's study the one by one. So the scatter diagram method is the simplest method to study the correlation between the two variables, wherein the values in each part of a variable is placed in a graph in the form of dots, thereby obtaining the many points as the number of observations. Okay, here what is when we plot a graph and where we try to study the correlation between the variables. So in it is a graphical method. scattered in this is the form of graphical method. Here we want we plot points and try to study the correlation. So this was all about scatter diagram. Let's study the Spearman's rank correlation. The Spearman's rank correlation is based on ranks. Here we use the ordinal data set. Spearman's rank correlation measures the strength and direction of the association between the two ranked variables. Here first, what is done? The variables are arranged in order. They are ranked, ranks are allotted to them, and then the association between the two variables is studied. Okay, it basically gives the measure of monotonicity between the relation among the two variables. That is, that how well the relationship between the two variables could be represented using the monotonic factor. Here a monotonic function is used to find the relationship or the association between the two variables. It is the formula for this Spearman's coefficient of correlation is P is equal to 1 minus 6 sigma di square whole divided by n in bracket n square minus 1 bracket close. Okay, so I am repeating this formula once again. P is equal to 1 minus 6 sigma d square whole divided by n bracket n square minus 1. So this was Spearman correlation. Here P represents the Spearman's rank correlation coefficient. Then Di is the difference between the two ranks of each correlation. N is the number of observation, and the Spearman correlation can take the value from -1 to +1. Okay, the value of either Karl Pearson or either Spearman. The range of this value is it will range from +1 to -1 only. Okay, a value of +1 measures a perfect association of ranks. That plus, if the value is positive, then we say that the perfect association of rank exists. Then if the value is 0, that there is no association between the ranks. Then if the value is -1, then there will be perfect negativity association between the rank. I hope this Spearman rank correlation is clear. Then we have the most important one, Karl Pearson's coefficient of correlation. Karl Pearson coefficient of correlation is extensively used a mathematical method in which the numerical representation is applied to measure the level of relationships between the linearity related variables. Here what we are trying to say, this method was given by Karl Pearson, so that's why the name is Karl Pearson coefficient of correlation. Here the coefficient of correlation is extensively used as a mathematical measure so that here what we are trying to how well the linearity variables are associated among themselves. The coefficient of correlation is represented by R. This is not 0, this is just R. Here it's typed by mistake, sorry. So the Karl Pearson coefficient is denoted by R. Then here yes, it is the widely used mathematical method where the numerical expression is calculate the degree and direction of the relationship between. Here the method is mathematical where we check the degree and direction of the relationships. Okay, then Pearson's method, popularly known as Pearsonian coefficient of correlation, is most extensively used in quantitative methods of practice. Where the methods practiced are quantitative in nature, in such methods we are used Pearson coefficient method, Pearson correlation coefficient method to understand the association between the variables. Okay, I hope you are understanding. The association of correlation is denoted by R. Same points were there, just the another name we get to know here. Now let's understand what are the properties of Pearson correlation. Here the properties are very important. That the first one is common, which we have studied in rank correlation, that the value will always exist between -1 and +1. Okay, here the value will exist between -1 and +1. Then point 2 is what? If the relationship between X and Y is positive, then the R will be positive. This point is, remember, because there is a direct relationship. If the relationship is positive, then the value of correlation will be positive. Then if the relationship between X and Y is negative, the R will be negative. It's very simple terms it is expressing that if X and Y are positively correlated, the R will be positive. If they are negative correlated, it will be negative. Then fourth one is if there is no relationship between the X and Y, then it will be 0. There is no correlation, then the value will be 0. 0.5 says that the value of R will be +1 if the points X, Y lie on the straight line with positive slope. The X line, which we have said in case of linear correlation diagram, was there. This one. If the line is flowing in the positive, is moving in the positive direction, then the value of R will be positive. It's simply saying this. Then 0.6 says what? The value of R will be +1 if the points of X, Y lie on the straight line with positive correlation. Oh, same point is repeated there here. Then one more important property is there, which I would like to tell you, that which is asked in exam many times, that this one. Here. This property is very much important, that correlation coefficient is independent of change in both change in origin and change of scale. So that was the point which I was telling you. Now let's see there are some Pearson Maharaj has given some assumptions related to his method. So what are these assumptions are there? Let's see. The measures are approximately normally distributed. These measures are normally distributed. Avoid using the highly skewed data. Here, skewed data will not be used, or data will be multiple modes will not be used. They should be approximate the bell-shaped curve. Data should be normally distributed. Point 2, that the variance of the two measures should be homogeneous or homoscedasticity. Check with the scatter plot. Here whether the variance of the two measures is similar or not, it can be checked with the scatter plot. Then point 3 is the sample represents the population. The sample should represent the population, then only the correlation between the variables will exist. If your sample doesn't represent your target population, then your correlation won't mean anything. Okay, if the population, because why? Statistics is what? It's the study on the it's all that your sample should represent your population. Then these are the three important assumptions which are related to Pearson's coefficient of correlation. First one is that normal distribution, then the variance of the two variables, two measures should be same, and the sample should represent the population. Now, this is the formula of coefficient of correlation. R is equal to summation xy minus summation x into summation y, then whole divided by under root n summation x square minus summation x square, then bracket close, and in the another bracket n summation y square minus summation y square square. Okay. So this is the correlation coefficient formula. Now here another thing is given, that when the deviation is taken from the actual means, here we have been given another formula, that Rxy is equal to summation xy divided by under root x square summation x square into summation y square. This is another formula. When the deviations are taken from the assumed mean, we use this formula. Here R is equal to what? N summation dx dy minus summation dx into dy whole divided by n summation dx square minus summation dx whole square multiplied by n summation dy square minus summation dy whole square. So this is the whole formula of our Pearson's correlation. Now here the 6 degrees of different types of correlation. This slide should be earlier, but here is now. Given the straight line, the points are on the straight line, there will be strong positive correlation. When the points are away from the straight line, it will be weak positive correlation. When the line is negatively sloped and the points are lying on it, there will be strong negative correlation. Then when the points are away from the negatives on the negative sloped line, it will be weak negative correlation. When the points are lying nearby to that line, it will be moderate negative correlation, and when there is no relation between the points, there will be no correlation. These are the different degrees of the correlation. Now we have ended with the correlation. Now we will start the regression. Regression method was given by the person Francis Galton. Remember his name. Francis Galton was the person who coined the term regression. Okay, regression is a technique used to determine the statistics relationship between the two or more variables and to make the prediction of one variable on the basis of another variable. Here regression is what? Regression, we talk about only two basic things, that is correlation, cause and effect relationships and prediction. Here value of one variable is predicted by using another variable. Okay. Then here two variables are used. Dependent variable is regressed or explained, and the independent regressor or predictor or the explanatory. Okay, explanatory variable. So this is the basic definition of regression. Remember this name, regression was given by Francis Galton. Now let's understand what's the importance of regression analysis. Regression analysis helps in three important ways. It helps, and these are the 3 points which tells the importance of regression, that it provides the estimate of values of dependent variables from the values of independent variables. You can estimate the values of dependent variable from independent variable. Then it can be extended to 2 or more variables, which is known as multiple regression. If the values are extended greater than 2, then it will be termed as multiple regression. And point number 3, it shows the nature of relationship between the 2 or more variables. When it tells the relationship between 2 or more variables, it is called as the nature. What is the type of relationship? It can be understood by regression analysis. Now we have properties of regression coefficients. Regression coefficient also has properties. This statistics is completely full of properties and formula, nothing else except in this unit, because it is all about rote learning. If you know the property accurately, you know the reason behind why it is happening, then you can easily answer the question. Okay. All these things you have to remember, because by remembering this only you will be able to answer the question. It's a small brother of which one? Your higher education. There were only the years and names, author's name were there, but here different things are there. Let's take a 30-second break. Let me have water. Okay. So we were discussing the properties of regression correlation. The coefficient of correlation is the geometric mean of the two regression coefficients, that is that R is equal to bxy into byx. Okay, both the regression coefficients must have the same algebraic signs. The algebraic signs of the regression coefficient should be same. Okay, then point 3 is the coefficient of correlation cannot have the same sign as that of the regression coefficient. The sign of the correlation coefficient and the regression coefficient should be different. Okay, Then point number 4, the both of the regression coefficient cannot be greater than unity. The value of both regression coefficient should not be more than 1. Okay. Then arithmetic mean of two regression coefficient is equal to or greater than the correlation. The arithmetic mean, if we calculate the arithmetic mean of two regression coefficient, it will be either equal or greater than the value of the correlation. Okay. Then here one formula is there, bxy plus byx divided by 2 is either equal to or greater than r. Okay. Then regression coefficient is independent of change of origin but not scale. Here one major difference arises that generally people get confused here, that the correlation is independent of both origin and scale. Neither the origin has any impact on the correlation nor the scale will have any impact. But in case of regression will be affected by origin but not scale. Okay, remember these points. Regression coefficient will be independent of origin, but the change in scale may affect it. Now let's understand the regression equations using the regression coefficient using actual values. Here the regression coefficient which we used to calculate in our MBA, MCOM. So regression equation y of y on x, y minus y bar is equal to b y x, x minus x bar, where the b y x is equal to n summation xy minus n summation x into summation y whole divided by n summation x square minus summation x whole square. कितने बार रट्टा लगाया होगा अपने बीकॉम एमकॉम में इसको? The x minus x bar is equal to bxy y minus y bar, where the bxy is equal to n summation xy minus n summation x into summation xy whole divided by n summation y square minus summation y square. Sorry, minus summation y whole square. That simply seem whenever you see at this bxy, let me tell you, whenever you see this bxy na, and you have to find x on y, what will go in the denominator? The y will go on the denominator. Okay. And when you have to calculate y on x, here x will increase, here the x will come in the denominator. This is the best way to remember the regression equations. Then here y is equal to a plus bx, another, and how will you determine the value of b? B can be determined by n summation x into y minus in bracket summation x into summation y whole divided by n summation xy x square minus n summation x ka whole square. Okay. And a is calculated by a is equal to summation y plus b into summation x whole divided by n, where the n is the number of observations or years, then x is equal to a year index decade, and y is the population size for a given census years. So this is this formula is applied in another case. Mainly you have to remember these two regression equations. So here these equations are given in the another form. In case of y on x, it will be a plus bx. A is equal to y minus y bar. Same is there. There is nothing difference. Only the difference here. Here is main difference. That is y minus y bar. To y represent find the y minus y bar is equal to r multiplied by summation x into summation y divided by not summation, sorry. Let me tell you again. Y minus y bar is equal to r into summation y whole divided by summation x. It's not summation y, my mind is not working. It's sigma y upon sigma x is there. Okay. And x minus x bar. Sorry for the confusion. Sometimes it happens when you are teaching from since long hours, it happens. And then regression equation. x on y. X on y, in case of x and y, this will be a plus by, x is equal to a plus by. Then x minus x bar is equal to bxy minus bxy multiplied by y minus y bar square. Okay, then x minus x bar is equal to r multiplied by summation x summation sigma x whole divided by sigma y multiplied by y minus y bar. Why this Francis Galton, this stupid fellow, has given so many formulas? These are very shameless people. They don't care that how our net aspirants, how my students will remember all this formula. They have to remember the formula of coefficient of correlation, coefficient of regression, coefficient of all the measures of central tendency, dispersion, kurtosis. How much formula we will good, and in case other than this, finance has different relations, finance has different formula, accounting has different formula, either the economics has its own relation, another static portion is there in different units. Sometimes I think that our mind will get busted if we try to memorize all this formula. No need to worry. You just write it down, paste it on your wall where you are studying. Within the within a week, it will automatically, you will be able to recall from the identify from the option what is the correct formula of the regression equation. Either it is correlation coefficient, either it is dispersion, or either it is central tendency. Any type of formula you can easily identify. Just you need just took a piece of paper, just write all the formula of statistics and paste it on a wall. Or you can paste it on your study table also, where your paste it at such place that where your eyes are frequently catching that. By this, it will be set up in your. Before this, we have done 3 topics that are the correlation, standard dispersion, and central tendency. Now we are starting with hypothesis. Before that, there was I taught you skewness, but there was a topic left over here, kurtosis. So let's discuss what is kurtosis. So kurtosis is a statistical measure that how heavily the tails of a distribution differ from the tail of a normal distribution. In other words, the kurtosis identifies whether the tails of a given distribution contain extreme values or not. So what kurtosis does, it checks that either the tails of the extreme contains the extreme value or not. Kurtosis, simply remember a word, that is peakedness. Whatever the peakedness of the normal distribution curve will be told by the kurtosis. Okay, so here is the diagram of kurtosis. Here the middle one is the normal distribution curve. This one is the normal distribution curve where all the mean, mode, median are equal. And then above this, this is the normal distribution called is mesokurtic. So you can remember which NM. NM means normal distribution curve and M means is the mesokurtic one. Okay. Then you have platykurtic. Platykurtic means the positive kurtosis is called as leptokurtic. You can remember it by PL. Okay, leptokurtic, whatever the positive highest level of kurtosis, it will be called as leptokurtic. And the negative kurtosis, which lies below the normal distribution curve, it will be called as platykurtic. Okay, so NP you can remember and PL you can remember. Platykurtic, the positive skewness will be called as positive kurtosis will be called as leptokurtic, and negative kurtosis will be called as platykurtic. Okay, you can remember here, that is PL, positive kurtosis leptokurtic, normal distribution curve mesokurtic, and negative kurtosis means platykurtic. So LAMP is also a mnemonic by which you can remember all these 3 lines. M is A is not considered. This A is not considered, but here leptokurtic, mesokurtic, platykurtic. Let's start with the hypothesis testing. Hypothesis testing is a quite complicated topic, but don't worry. Listen to me careful. you will be able to understand the tests and all the basic concepts in the hypothesis. So let's understand what is hypothesis. All of you might have studied in this paper 1 research aptitude that hypothesis what? It's just an assumption, a tentative statement which we form while doing the research. Okay, first let's understand that hypothesis will indicate the relation between the two variables, and what it will tell. First, the research question will be formed, and then only after formulating the research objective, the hypothesis will be formed. Okay. Now we have features of good hypothesis. What should be the features of good hypothesis? Let's see one by one. So it should be capable of being tested. Hypothesis will be considered good if and only if it can be tested. Then it does not conflict with any law or nature well known to be true. When hypothesis is true, it should not clash with any type of law or nature. Okay. Then hypothesis should be clear and precise. Though no lengthy hypothesis should not be there. It should be it should be both clear and precise. The hypothesis which we are making should be clear and precise to understand. Then the hypothesis permits the application of deductive reasoning. Deductive reasoning, you all of know that is. Deductive reasoning means whenever we verify a theory, it is called deduction. Okay. Then here a good hypothesis is showed. A good hypothesis shows. Sorry, it has come twice. A good hypothesis ensures that method is very clear verbalization. The verbalization should be very clear in case of hypothesis. Then methods of the verification under the control of the investigator. Whenever the hypothesis is being verified, it should be under the control of investigator. Okay. Then a good hypothesis guarantees that available tools and techniques will be effectively used for the purpose of verification. Whenever the hypothesis testing is done to verify, it should see the investigator should check that proper tools and techniques will be applied or not. And then hypothesis should be amenable to testing within a reasonable time. It should not take much time in a testing of hypothesis. It should be done in as soon as possible in a best way. Okay. Then a good hypothesis indicates clearly the role of different variables involved in the study. Whatever the variables are involved, a hypothesis should represent that there is some relation exists in the study or in between the variables which are being studied. Then it is prior to the scientific research. Hypothesis, it's a pivot, means it's a tentative statement which is very much essential in case of a scientific research, and it supports the research objective. Hypothesis should support the research objective, then only it will be called as valid hypothesis. Now let's see, this is the important difference that null and alternate hypothesis. I will tell in brief because you might have everyone of you know this. When there is no relationship between the variables, it is called null hypothesis, and when the alternate hypothesis, when the relation between the two variables exists, it will be called as alternate hypothesis. Alternate hypothesis has different names like researcher hypothesis and substantive hypothesis. Sorry. Then let's see the second one, that the null hypothesis has no observed effect and alternate hypothesis has some observed effect. Then null hypothesis is what the researcher tries to disprove. Null means ND, means the researcher tries to disprove, and alternate hypothesis is AP, when the researcher what the researcher tries to prove. Okay, then acceptance, no changes in the opinions or actions. There are no changes in the opinions or actions. Then in case of alternative, there will be changes in the opinions or actions. Okay. Then the testing. Indirect and implicit testing will be there in case of null hypothesis, and direct and explicit testing will be there in case of alternate hypothesis. Then the observations are observation result of a chance in case of null hypothesis, and observation will have a real effect in case of alternate hypothesis. Then it is denoted, null hypothesis is denoted by H0 and alternate is denoted by H1. Then the mathematical formulation, in case of null hypothesis, we will use this sign, equal sign, and in case of alternate hypothesis, we will use unequal sign. Okay, this will be used. Now we have another important concept, that is type 1 and type 2 error. Type 2 error are very simple to remember. Why people get confused in it? When the hypothesis is right and you rejected it, it will be called type 1 error. Then when the hypothesis was false and you accepted it, it will be what? The type 2 error. Okay. Now let's understand from this chart. It will make you clear. Type 1 error refers to the non-acceptance of the hypothesis which might be accepted. Whatever the hypothesis was right, but you not accepted, you rejected the right hypothesis, so that is what? It's non-acceptance, so it will result in type 1 error. And the type 2 error is what? Type 2 error is the acceptance of hypothesis which ought to be rejected. You have accepted the wrong hypothesis, that will lead to type 2 error. Okay, then type 1 error is lead to false positive, and it type 1 error is false positive and type 2 error is false negative. Okay, then what is it? Third point comes, what is it? So type 1 error is incorrect rejection of null hypothesis, and type 2 error is correct acceptance of false hypothesis. When the null hypothesis was false and you accepted it, it will result in type 2 error. Okay, then it represents, type 1 represents a false hit and type 2 errors represents a miss. Okay, then the probability of committing error, committing the type 1 error is equal to the level of significance. Remember this point. Sometimes it give you in match the column type question that it is equal to the level of significance, type 1 error, and in case of type 2 error will be equal to power of test. Okay, and the symbolic representation of type 1 error is alpha and the symbolic representation of type 2 error is beta. How many times we have studied it, we don't know in this past 6 months. So I hope this is clear. Now we are starting with the hypothesis testing topic. Hypothesis testing is what? It is a type of statistical analysis in which you put your assumption about the population parameter to the test. It is used to estimate the relationship between the two statistical variables. Hypothesis testing is what? It is a method where we try to test that, check that where any relationship exists between the two variables or not. Okay. Then we have the hypothesis testing procedure. What is the hypothesis testing procedure? Let's see. First, what will we do? We will set up the hypothesis. First of all, a hypothesis will be set up. Then a suitable significance level will be set up. Then we will determine the suitable test statistics. We will determine the suitable test statistics. Then we determine the critical region. Critical region will be determined, and after it, computation will be done. Then we will make the decision. Decision making will be done. It will be the last step in the hypothesis testing procedure. Okay. So I am repeating because stepwise questions are very much as famous in NTA UGC net nowadays. So first of all, what we will set up the hypothesis, then we will set up the suitable significance level, then we determine the suitable test statistics, then we determine the critical region, then we perform the computation, and at last we will make the decision. Now see, let's difference between one-tail and two-tail test. Earlier before this we have seen that null and alternate hypothesis and the type 1 and type 2 error. Now here we are starting with the one-tail and two-tail test. One-tail test is a statistical hypothesis test in which alternative hypothesis has only one end. It is known as one-tail hypothesis. When the alternative hypothesis has only one end, a particular dimension is mentioned, a particular direction is mentioned, it will be called as one-tail test. In case of two-tail test, a significance test in which the alternative hypothesis has two ends is called two-tail test. Whenever there will be one end, it will be called as one tail, and whenever two end will exist, it will be called as two-tail tests. Okay, then the one-tail test will be directional, and the two-tail test will be non-directional. Okay, then the region of rejection will be either left or right, but in case of two-tail direction, you have both left and right can be the region of rejection. Okay, then one-tail test determines if there is a relationship between the variable in single direction. Where the relationship exists between the variables in a single direction, we check in one-tail test, and in case of two-tail test, we check that if there is a relationship between the variables in either direction, in either any of the either forward or backward direction, which among these two, where the relationship exists, we try to find in case of two-tail test. Okay, then the result of the null one-tail test is greater or less than the certain value. The hypothesis, the result of the test will be, in case of one-tail test, it will be greater or less than the certain value, and in case of two-tail test, it will be greater or the less than the contain range of values. Range of values will be there. It will be lesser. The result of the test will be either greater or less than the range of the values. Okay, then a one-tail test is denoted by either less than or greater than sign, and here our two-tail test is equal to not equal to sign. This is the symbol signs used. Now, if you have still any confusion, let me remove it. So boys are less intelligent than girls. Now here people will say, ये क्या मजाक लगा है, लड़कियों को ही हमेशा प्रेफरेंस देते हैं, मगर this is the real truth. This is the real truth. Boys are also intelligent, but here either I will write boys or girls are intelligent. Either boys or girls are intelligent. Here you have no direction, but here this will be your two-tail test, because here no direction, direction is not mentioned, but here one directional is mentioned, so it will be one-tail test. Here you have given no two directions. Either you can go this side or you can go this side. So it is two-tail test, and it is in case of one-tail test will be there. Here they are specifically mentioned that boys are less intelligent are girls. The fact is just opposite than this. Jokes apart. So I hope with this example you won't confuse in case of one-tailed or two-tail test. Let's move. Now we have level of significance. Level of significance is what it determines by the researcher. Level of significance in the while studying the steps of hypothesis, we find this step that setting the level of significance is an important step while hypothesis testing. So it will be defined by a researcher, and it is symbolized by denoted by alpha sign. Okay, then it is affected by the sample size and the nature of experiment. It will be affected by the sample size. What is the size of the sample, it will affect it, and what is the nature of the experiment, both may affect the level of significance. Just a second. Let's see. Common levels of significance are 0.5, 0.01 and 0.001. These are the common levels of significance. Then level of significance, what it does, level of significance indicates the probability that the researcher made an error in the rejecting the null hypothesis. कितने चांस है कि आपका null hypothesis reject होगा? It will be determined by which one? Which it will be determined by the level of significance. Okay. Now we have some terminologies are starting, so be attentive. The critical region. Critical region is what? Critical region is the value is the region of the values that corresponds to the rejection of the null hypothesis at some chosen probability level. At some chosen probability level, it will indicate some values, region of values where there is a chance that the null hypothesis will be rejected. Okay, the shaded area under the student t distribution curve is equal to the level of significance. The shaded area which is under the student t distribution will be the level of significance. Okay, when the critical values are evaluated, and thus obtained from the student's t table or another appropriate table, if the absolute value is of the t statistics is larger than the absolute value, then the t in the critical region, then the t is the critical region. Okay, so one-tailed or two-tailed test are used here. Okay, then the statistical test used will be either one-tailed or two-tailed depending upon the it. Now, if you see this diagram here, the portion which is in this color, this portion is called as the critical. Whatever the values will come here, it will be called as the critical region. This whole region, this will be all these things. This will be covered in the critical region. Okay. We have discussed the critical region. Now we are dealing with the critical value. Critical value defines the region of the sampling distribution of the statistics. These values play a role in both hypothesis tests and confidence intervals. The critical values have both an important role in hypothesis testing and determining the confidence interval. In hypothesis testing, the critical values determine whether the results are statistically significant. To check that these critical values are determines that whether the results are statistically significant or not. For confidence interval, they are helped to calculate the upper and the lower limit. For the confidence intervals, these critical values helps to determine the upper and the lower limits. Okay, if this condition is very important. If the absolute value of your test statistics is greater than the critical value, you can declare that the statistical significance and reject the null hypothesis. Then you can declare that the statistical significance exists and you can reject the null hypothesis. I hope the concept of critical value is clear. So whatever the values were lying here, just a second. Whatever the values were in this region, suppose at this point, whatever the values will be there, it will be called as critical value. Okay. And this region, the tails of the normal distribution curve beyond that line area, it will be called as critical region. Okay. That means the region of rejection. Now we have standard error. Standard error, the standard error of the mean or simple standard error indicates how different the population mean is likely to be from the sample mean. It's a standard error simply means that it tells that how the population mean is likely to be different from the mean. The difference between the sample and the population mean is called as standard error. Okay, it tells you how much the sample mean would vary. How much the sample mean would vary if you were to spread. You will repeat the study between the two new sample from within the single population. Suppose you have this is your population and this is your sample. Here the difference between, if both two are different, it will be termed as standard error. Okay. What will be whatever the difference will be there among this, it will be termed as standard error. Okay. Then standard error of mean will be the formula for calculating the standard error is SE is equal to S upon root N, where S is the standard error and N is the number of observations. Now the next one is the probable error. Probable error is used to test the probability of the correlation coefficient Okay, the probable error is used to test the validity of the correlation coefficient. The probable error of the coefficient of correlation is an account if which if added or subtracted from the mean correlation coefficient produces the amount in which the chances are even that the coefficient of correlation from the series selected randomly will fall. I hope some. Okay, that's right. I was thinking that is there any mistake or in this definition. So I hope this probable error, just you have to keep the formula is in mind. It will not be asked conceptually. Mainly the formulas are asked. So probable error is what? 0.6745 is there. Till 3 decimal we have to remember 0.674 into 1 minus r square upon root n. Okay, here r is the correlation coefficient of the pairs of observations for any random samples and n is the total number of observations. Now we are starting with the tests. Now here the difference is just take a break. It will be helpful for you because you might be listening from longer time. Now we have parametric and non-parametric test. Parametric test is what it assumes the normal distribution is mainly assumed in case of parametric test, and in case of non-parametric test, any type of distribution, either continuous or discrete, will be assumed in case of non-parametric test. Okay, then the variance. Variance is homogeneous in case of parametric test, and in case of non-parametric test, the variance can be either homogeneous or heterogeneous. Okay, then the typical data, ratio or interval data is used in case of parametric test, and in case of non-parametric, ordinal or nominal data will be used. Okay, then the data set relationship. In case of parametric test, the data set relationship will be independent, and in case of non-parametric, the data set will, any type of data set relationship will exist. Okay, then uses of which central tendency measure is used. In case of parametric test, mean will be used. In case of some parametric test, and in case of non-parametric, median will be used. Okay, then benefits. What are the benefits of parametric test? It can draw more conclusion. Parametric test can draw more conclusion, and in case of non-parametric test, simplicity and less affected by outliers. The simplicity will be there and it will be less affected by outliers. Now here comes what is the classification, what type of test comes in which test. So here the parametric test, we have paired t-test, unpaired t-test, then Pearson correlation and one-way analysis of variance, which is ANOVA. In case of non-parametric test, this is Wixon rank sum test, then Mann-Whitney test, then Spearman's correlation and Kushkel-Wallace test. These are all non-parametric tests. Okay, because sometimes either it can be asked in match the column, or in case of odd one out, or identify which among the following are parametric or non-parametric tests. This type of question can be asked from here. So you also have to keep in mind the difference between, because such comparison charts, you may be thinking that why sir brings so many comparison charts. The motive behind the bringing the comparison chart is that in charts we can get a lot of things cleared, which may help in statement type or a single type of question. Now let's understand what is chi-square test. Chi-square test is a statistics test that measures how the model compares to the actual observation data. Okay, how a model is compared to the actual observation data. The data used is calculating a chi-square statistics must be random, raw, mutually exclusive, drawn from the independent variables. Okay, the data, thus while calculating the chi-square testing, the sample should be drawn in a random variable and mutually exclusive way from the independent variables. and drawn from the large enough sample. The sample size in case of chi-square test will be large. Okay. For example, the results of tossing a fair coin. If a coin is tossed, either you will get a tail or head. Okay. So it meets this criteria. Then we have chi-square test, often used in hypothesis testing. The chi-square test statistics compress the size of any discrepancies. It compresses the size of any discrepancies between the expected results and the actual results. Any sort of discrepancies, the size is determined. It compares the size of the discrepancy between the actual results and expected result given the size of the sample and the number of variables in the relationship. I hope these things are, in case of such things, you don't need to go in depth, because you just have to remember why these tests are used and what are they. The best way to just keep in root learning form, because here direct questions are asked from test, no assertion, reason, or no longer, no indirect will be asked, only the direct, either related to the characteristics, the formula, the conditions, or the assumptions will be asked. So don't worry about the test, because simple direct questions are asked. Then the characteristics of chi-square. What are the characteristics of chi-square test? Let's try to understand. This test is a non-parametric test. This, you have to remember that chi-square is not parametric. It's a non-parametric test. It's based on the frequencies, not on the parameters like the mean and standard deviation. It's not based on any type of central tendency or dispersion measure. It is based on the frequencies. Okay. Then the test is used for testing the hypothesis and non-useful in estimation. It is not used in case of estimation. It is used in case of hypothesis testing. Okay. The point 3 is the test possesses the additive property has already been explained. The test has some additive properties. Okay. Then the test can also be applied on a complex contingent table. The test can be applied on a contingent table where the several classes are there, and as such very useful in case of research work. In case of research work where the contingency table we can use this, and in case of contingency complex table, this test can be applied to find to check the validity. Okay, this test can be important non-parametric test. This is an important non-parametric test as to rigid assumptions as necessary in regard to the type of population. As in regard to type of population, no need of parameters value. There is no need of parameter values, and relatively less mathematical details are involved. Here, less mathematical details are involved in case of parametric, in case of chi-square test, which is non-parametric in nature. Then what is goodness of fit? Goodness of fit is associated with the chi-square test. One of its terminology, let's see it. The term goodness of fits refers to the statistical test that determines how well the sample data fits to the distribution from a population with a normal distribution curve. It checks that, basically it checks that what is the, either the sample fits with the normal distribution or not. Simply the hypothesis, it hypothesizes whether a sample is skewed or represents the data you would expect to find the actual web population. Whatever the data you want to find out from the actual population, it hypothesizes that whether it is representing or it is skewed. This is the main task of the goodness of fit. Then we have the formula. It will be represented by chi-square sign. Then chi-square is summation OI minus EI square divided by EI. Okay, here the OI means observed value of the or the actual value, and EI is the expected value. Okay, simple formula: observed minus expected whole square divided by expected. Then we have t-test. What is t-test? Let's study. T-test was given by Carl Gosset. Okay, remember this. It is also called as student t-distribution, because sometimes NTA changes the names to confuse us. A t-test is a statistical test that is used to compare the means of two groups. Here the means, it being a parametric, as it is a parametric test, means of two groups are compared together. It is often used to in hypothesis testing to determine whether a process or a treatment actually has a effect on the population of the interest, or whether the two groups are different from one another, whether the two groups are different from another, or to compare the means of the two groups, this t-test is being used. The t-test was given by Carl Gosset. Okay. So here are some assumptions of 5 assumptions of associated with the independent sample t-test. Let's see them. Independent sample is, the sample should be independent. Okay. Then interval or ratio level data is used. Then random sample, robust, but that may not impact the generalization. Then fourth one is normality, robust if there are large and about to equal. T-test is generally used when the sample size is small. Okay. Then the homogeneity of variance, robust if it is the large and robust equal and about equal. I hope these assumptions are clear. There is nothing to understand in the assumptions. You have to just eat it in the means you have to just learn it as it is. Now here is the formula of t-test formula. That t is equal to x bar minus mu whole divided by sigma upon root n. Then what are these values? Let's understand that x bar, you know, it's the mean of the sample. Mu is what? The assumed mean. Sigma is what? The standard deviation. And the n is the number of observations. Now here let's do a quick revision of where it is a given best chart that what type of test should be used when. So here in case of ANOVA, when you compare the means of more than 2 samples, mainly we use ANOVA. Then we have when we should use the chi-square test. Chi-square test is used generally to test the goodness of fit to an assumed distribution. When there is an assumed distribution and we have to test the goodness of fit, we will use the chi-square test. Then F distribution, F test, when will be the F test will be used when we have to compare the variance of the 2 samples, we will use F test. Okay. Then when the T test is used, T test we have just seen in the previous slide, when the means to a value or the means of 2 different samples are compared together, we will use the T test. Okay. Then in case of X square, Z test is what as T test, but not the for large sample. For large sample, we will use the T test. The functioning of the Z test will be same as in T test, but here we are using the large sample size. I hope this chart is clear. Now here we have again a comparison chart will make you clearly understand what are the differences between this t-test, z-test and f-test. So t-test was given by Gosset, z-test was given by Fisher, and f-test was also given by Machli, means Fisher. Okay, jokes apart. Then t-test is for sample, small sample, f-test is also for small sample, but the z-test is for large sample. Okay, and then we have the third one. The third point, what does it say? Population correlation coefficient is 0. Here the population correlation coefficient is 0. Then here the population correlation coefficient is not 0. In case of z-test, the population correlation coefficient won't be 0. And in case of f-test, the 2 dependent estimation of the population will be there. Okay. Then in case of t distribution, the variance will be unknown. Then in case of z-test, the variance will be known. And in case of f-test, the variance will be same. Okay. Then in case of t-test, we are discussing the last point, that in case of multiple regression with the individuals, when we have the multiple regression with the 3 individuals are there, we will use the t-test. And in case of when there is no such condition in z-test, in case of f-test, we will test for the overall significance. When we have to test the overall significance, we will discuss the z-test. Sorry, we will use the f-test. Then what is f-test? We have already seen that it is a test which is used for f-test statistics to check whether the variance of the samples or the population is equal to same values. Okay, this was the f-test. We have already seen twice in the charts. I hope it's not necessary that I should tell here in again. It will waste our time. Then let's see what are the characteristics of F distribution. What are the characteristics of F distribution? Let's see that there is a family of it is a family of F distribution. Acha ji. Then each member of the family is determined by two parameters, the numerator and the degree of freedom and the denominator degrees of freedom. Okay, then F cannot be negative. The value of F will not be negative. It's a continuous distribution. It will be a continuous distribution. The F distribution is positively skewed, and the last one is the value ranges from 0 to infinity. The values will relate to range from the 0 to infinity. As F is infinity, the curve approaches to x-axis. Whenever the value is equal to the infinite value will be there, the curve will approach to the x-axis. Then we have the Z-test. Z-test we have already discussed in the chart. It refers to a univariate statistical analysis used to test the universal statistical analysis, where what you will do, you will test the hypothesis that the population from the two independent samples that differs greatly. Whenever the two samples differ greatly and the sample size is large, here you will apply this univariate test to, and that sample should be independent. Okay, it determines to what extent the data point is away from the mean. How much the data points are away from the mean, it will determine determined by using the Z test, and here the standard deviation is used. Okay, let's see its assumption. What are the assumptions of Z test? All the sample observations are independent. Here all the sample observations are independent. Then sample size should be more than 30, means the sample size should be greater. Then third one is distribution of Z is not normal with mean 0 and variance. The distribution of Z is normal, means normal distribution is used. Then the formula of Z test. What is the formula for this Z test? Is x minus mu 0 whole divided by sigma upon root n. This is same as t test. No, it's little bit different. Then okay, the x bar is the mean of the sample, mu is the mean of population, then sigma is the standard deviation of the population, and n is the number of observation. Let's see the ANOVA test, means the analysis of variance. ANOVA is the full form of ANOVA is the analysis of variance test. It is invented by R.A. Fisher in 1920s. Okay, ANOVA is used the test to test the significance of the difference between more than two samples, to check the difference between the to test the significance of the difference between the two sample means, and the make inferences about whether our samples are drawn from the population having the same means or not. We use the ANOVA test. Okay, the ANOVA is powerful and common statistical procedure in the social sciences. It can handle the variety of situations. ANOVA is used in case of multiple situations, and it is a powerful statistic procedure to understand, to deal with the social sciences. Okay, and here what we study, where we infer that whether the sample are drawn from the population have the same means or not. Then we have one-way ANOVA. One-way ANOVA is what? One-way ANOVA test is the relationship between the categorical predictor or the continuous response. Categorical predictors or the continuous response will be there. When in case of standard, here we'll check whether there is a equal variance between the groups of the categorical features with respect to continuous response. Here we will check that whether the equal variances between the groups of the categorical feature has the continuous response or not. And the point 3 indicates that if there is an equal variance between the two groups, it means that the feature has no impact on the response and cannot be considered as a model training. It cannot be considered as a model training if there is no impact on the response whenever the equal variances are there. I hope this is clear. Now we have the two-way ANOVA. Two-way ANOVA is what? Two-way ANOVA technique is used when the data are classified on the basis of two factors. When the data are classified on the basis of two factors are classified, it will be called as two-way ANOVA. Okay. Such a two-way ANOVA design will have a repeated measurements. There will be repeated measurements of each factor will be there and may not be have repeated values. Okay. Then this is the best chart which will help you to remember. I recommend to take the screenshot of this chart because here what is the test statistics? First we have Z square, Z score or Z test will be used. And the sample size will be Z test two population or large sample greater than 30. Then what is information given? The information is given that the standard deviation of the population will be given in the form of sigma. Sigma will used and the population mean or the population will be used. Okay. Then the type of distribution will be normal distribution there, and the test question will be do the population do these two population differ or not. Then we have the T statistic, T or the T test. When the in case of T test, the sample size will be small and the standard deviation of the sample, this will given as the S and the sample mean. Okay. Then here also the normal distribution will be used, and here the test question will be do these two samples differ or not. Then in case of F test, F statistics or ANOVA, there are 3 or more samples will be there, and the whatever the information gives, it give information about the two group sizes, group means and group standard deviation. Okay. Here the normal distribution will be used, and do any of these three or more sample differ from each other or not. Then we have the chi-square test. Chi-square test means what? Here also there will be two samples, and what is information is given that the number of information for each categorical variable is there, and here any sort of distribution will be used. Why? Because chi-square is a what? It's a non-parametric test, and here are these two categorical variables are independent. The two categorical will be variables will be independent. Studying the important concepts of operation management. Operations management, OM. OM is what? It deals with the operations. Specifically, the word, what does it suggest? Ki whatever the operations are within the performed within the organization, either it is related to anything, so we have to properly manage it. For this, the concept of operation management is used. Now let's see from here. Operation management is the administration of the business practices to create the highest level of efficiency possible within an organization. It is concerned with the converting materials and labor into goods and services as efficiently as possible to maximize the profit of an organization. What we have to do, we have to use the raw material, the labor, and convert into the goods and services in a very efficient way, so that the profits of the organization can be increased. Then organization management teams attempt to balance the cost with the revenue to achieve the highest net operating profit as possible. From the operation management teams are there in an organization which balance the cost and revenue of the business. So now let's see some topics. Now this is facility location. Facility location and plant layout is basically mentioned in our syllabus, so we are studying it. What does facility location means? It simply means that where you are selecting a geographical site where you want to establish your plants. This location is very much important. Why? Because this sector, suppose you have this business here. This is your business site. Here you are producing, and here is the market. The market is very near, but the raw material is here, which is so far this side. So what you will, a large transportation cost will incur to bring the raw material. So that to avoid such type of hindrances, we should have to plan our site location, select the best site, considering so many factors. Now let's see from here. Facility location is the process of determining the geographical site for a firm's operation. What it deals with for determining the geographic sites, okay, for operation of the firms. Managers of both the service and manufacturing organizations must weigh mean factors when assessing the desirability of the particular site. When either a particular site should be selected or not, we use different types of method. Don't worry, the methods are in upcoming slides. It includes the proximity of the customer and the supply, labor cost, and transportation cost. These are some factors that how much distance is the market, how much distance is the raw material supply, what is the availability of labor in the labor market, and how much either they are costly or cheaper, and what is the transportation cost. These factors are considered in the facility location. Okay, then there are some location models which help. Various models are available in which, with the help of which we can identify the deal location. Some of the proper models are option 1.1 facility rating method, then weighted factor rating method, then load distance method, then center of gravity technique, and break-even analysis. These are the 5 major techniques which are used while planning a facility location. First method is that the factor rating method. What is the factor rating method suggest? It's the process of selecting a new facility location, involves a series of the following steps. In the factor rating, some certain factors are considered through, and this step is followed by which the decision regarding the particular site should be chosen or not is taken. So first of all, what we will identify the location factor. Then what we will do, then we will rate each factors according to its relative importance. Higher the rating indicative of the prominent factor. If the rating of the factors is high, it will be termed as prominent factor. Then we assign each location according to the merits of the location for the each factor. A certain location, either rural site, urban site, or suburban site, whatever it may be, each have its own merits and demerits. So according to the merits, the rating will be allotted, okay, for different location factors. Then we have fourth point. We will calculate the rating for each location by multiplying the factors assigned to each location with the basic factor considered. Whatever the basic factors are considered while locating the plant, while locating the facility location, here it will be multiplied with the ratings. And then in the last step, we will we will do the total of the product calculation for each factor and select the best location having the highest total score. Whatever the highest total cost of any site will be there, it will be selected. I hope this factor rating model is clear. Now we have weighted factor rating method. Weighted factor rating method is simply like the factor rating method. Here what we are doing, we are assigning weights. Okay. In this methods, a merge quantitative and qualitative factors are assigned weights based on the relative importance and weightage score for each site. Using a preference matrix is calculated. Okay, we are using a preference matrix as per your preferences, and the factors, both the quantitative and qualitative factors, are considered, and certain weights are assigned to them. And as per the weighted score, the site with the highest weighted score will be selected as the best choice. In each type of technique, such techniques, when the highest score will be there, it will be considered. It will be considered as the best choice. Now we have load distance technique. Before this, we have seen two methods, factor rating and weighted factor rating method. So what is the load distance method? The load distance method is a mathematical mode to evaluate the location based on the proximity factors. Here the distance factor is calculated, is considered, and all the factors which are study the mathematical model. This is the mathematical model where we study different location proximity factor to evaluate our location sites. The objective is to select the location that minimizes the total weighted load moving into and out of the facility. Suppose here what it is telling, that whenever a least movement will be there from the to and fro from the facility layout, that it will be selected. Okay, the distance between the 2 points is expressed in assigning the points to grid coordinates on the map. There is a grid coordination on the grid is coordinated on the map, and it is expressed through 2 points. An alternative approach is to use the rather than the distance. Here the instead of time is considered with respect another approach to use this time rather than the distance. Here we can use the load and time also rather than time and distance. Rather than load and distance. Now we have the fourth one, that is center of gravity technique. Center of gravity technique is primarily on the cost considerations. This technique is based on the cost considerations. Okay, then these methods can be used to assist the managers in balancing the cost and the service objectives. Here the proper balancing is done between the cost and the service objectives. The center of the gravity methods take into account the locations of the plants and markets. The center of the gravity methods use different plant and the markets, the volume of the goods moved, and the transportation cost in arriving to the best location for a single intermediate warehouse. Here what we are comparing, we are the amount of goods moved and the transportation costs which are incurred in arriving to the best location with the immediate with the intermediate warehouse. But between here will be the market here, and here will be the warehouse in between, and this will be the facility location, and here through this there will be some volume which will be transported to and fro the market to facility location. I hope this is the center of gravity technique. Now we have the last one, that is break-even analysis. This break-even analysis is simple, means that input should be equal to output, or the point at which the profits are equal to cost. Then the break-even analysis implies that at some point in the operation, total revenue equals to total cost. Here the total revenue at the point where the total revenue is equal to total cost will be termed as break-even point. Break-even analysis is considered with finding the points at which the revenues and costs are agree exactly. Where the revenue and costs matches, that point is termed as break-even analysis. Then we have plant layout. This was we have seen the facility location. Now we are studying the plant layout. According to More, the plant layout is a plan of optimum arrangement in the facilities, including the personnel, operating equipment, storage space, material handling equipment, and all the other supporting services, along with the degree of best structure to contain these facilities. What is being done, what the plant layout is, what here a proper spaces will be arranged for each thing, like personnel, where the equipment will be kept. Then there will be in some part of the organization there will be the storage space. Then some sort of material handling equipments will be there, and all these supporting and all the supporting services like for the movements and transports of goods. This should be designed in a best structure contains these facilities. So like here plant layout is what, actually plant layout is like a research design. The facility location is what, when we are actually selecting the site, and in case of plant layout you will design that how the things will be arranged in that particular site. So this we have done. Now what are the objectives of plant layout? Here some objectives of plant layout is mentioned. That first one is it's changing. streamline the flow of the materials through the plant. Here what we will do, we will streamline the flow of material through the plant from where it will go to where. Okay, then it facilitate the manufacturing process. It will facilitate the manufacturing process. Then it maintain the high turnover in the process inventory. In the process inventory, it will maintain the high turnover. Turnover will be maintained in the process inventory. Then it will minimize the material handling cost. Material handling cost will be minimized. Certain arrangements will be made so that the handling cost should be minimized. Then effective utilization of mean equipment of the effective utilization of the main equipment and space. In a proper space, there will be effective utilization of both the human and equipment. There should be proper allocation. Okay, then sixth objective is what? Make effective utilization of cubic space. Whatever the space which is just vacant, we have to use it in effective way. That will be covered under the sixth one. Then flexibility of manufacturing operations and arrangement. Flexibility of manufacturing operations and arrangement, that the operations and management should be operations for the arrangement should be arrangements for the operations or manufacturing operations should be flexible. Why? Because if any sort of changes are required, we should be able to do it. So flexibility is very important. Then provides for employee convenience, safety and comfort. The plant layout should be in such a way that the employee should not face any inconvenience in roaming, going from here to there. The proper safety measures should be taken, and it should be comfort. The environment should be in the manufacturing unit should be comfortable. Then minimize the investment in the equipment. The equipment should be whatever the funds which we are investing in the equipment, it should be reasonable. Okay, then minimize the overall production time. The facility plant layout should be done in such a way that there should be overall production time should be less. The production time which will be less, because what will happen if the production time is time consumption is more, it will lead to higher working hours, higher wages, and so higher usage of the all the overhead expenses related to the production. That will be to minimize all these things, we have to reduce the production time. Then maintain the flexibility of arrangement and operations. We have seen this. And facilitate the organizational structure. We have to facilitate. This is everything is done to facilitate the organizational structure. Then we have principles of plant layout. What are the principles of plant layout? Let's see. That is principle of minimum movement. Principle of the movement should be minimum. Then space utilization. Proper utilization of space should be done. Their flexibility is very much important to maintain in the plant layout. Then principle of interdependence. The things in the plant layout are dependent on each other. So the interdependence one activity should not be affected by the another. If any discrepancy happens in one, so it should be the things should be planned. The layout of the plant should be planned effectively. Then effective of overall integration. A proper integration between all the factors should be there. Safety should be there. Then smooth flow. The flow between the during the manufacturing period should be a smooth. From raw material will come from here. Then it will it will be loaded in the machinery, then the output will be dispatched to this certain unit. So this process should be, there should be smooth flow among this step. Then economy, the whole entire plant layout should be economic. Then supervision, less supervision should be required, and effective supervision can be done in an effective way. A provision of supervision can also be done in a plant in case of plant layout. Why? Because if excessive supervision is required, then you have to keep a separate person. But in case of if things are effectively arranged, people are properly trained, then you will not have to that much supervise. Okay. Then principle of satisfaction. There should be satisfied. The customer and management should be satisfied by getting the products and by production in an efficient and less costly way. So these are all the principles of plant layout. Now the plant layout are generally classified into 4 parts. One is process layout, which is associated with the process, which is in which the manufacturing is going to be done. It is associated with the process. Then is product layout. Product layout, when the one product is transferred from one unit to another unit, this is will be considered as a different products are in different units. That will be termed as product unit. Then combination layout. This is the layout is combination of both the products and processes. And fixed position layout. Here certain things will be there which will not be movable from once they fixed. So this is covered under the fixed position layout. Just take a break of 1 minute. Sorry, 30 seconds. So let's resume. We are discussing the total quality management. This topic is specifically mentioned in your Unit 8 syllabus. So total quality management, one question is asked from any of this topic. Total quality management is the continual process of detecting and reducing or eliminating the errors in the manufacturing, streamlining supply chain management, improving the customer experience, and ensuring that the employees are up to speed with the training. Whenever we talk about the quality matters a lot in whenever a product is sold to the customer. So during the after setting the quality standards regarding a product or services, we need to monitor and detect and eliminate all the errors in the manufacturing. We have to streamline, keep monitoring the supply chain and improve the customer experience by ensuring that the employees are providing the service in an effective qualitative way. Okay, then total quality management aims to hold all parties involved in the production process accountable for the overall quality of the final product or services. The actual production department will be accountable for the final product or service which is dispatched to the customer. Let's see the concept of quality. Quality matters a lot for any type of product and services for a customer. Whenever we go, why do we go to such reputed stores to buy the products, or to reputed restaurants like Pizza Hut, Domino's to have a certain dish? Why? Because these are people are maintaining quality. Why? Because if quality products or services will not be provided, then the customer will not rebuy your product and your organization will get into losses. To avoid this, we have to maintain the quality. Then what is quality? What does quality actually means? Let's see. Quality is the totality of features and characteristics of a product or services that bear on its ability to satisfy the given needs. Then according to American Society of Quality, what they have said, that it is the sum total of all the features and characteristics which has an ability to satisfy the customer needs. Okay, then quality is inherent distinguishing characteristics, a degree of grade or excellence. Quality means what? It is a inherent distinguished characteristics where we focus on what? We focus to provide our service at the excellent level. Quality should be excellent. Then we have statistical quality control. Statistical quality control is an application of statistics and analytical tools to monitor the process outputs. Quality, or SQL, involves in general category of statistical tools used to evaluate the organizational quality. Here statistical quality control is just a measure where we are using the statistical techniques like either descriptive or
in acceptance sampling, such techniques are used to what to check on the to monitor and evaluate the quality of the overall organization. Quality improvement is the reduction of the variables in the process of production. Here we are you are trying to improve the quality by reduction the variable in the process and products. Now we have what are the characteristics of quality control categories. Sorry. Not characteristics, it's categories of statistical quality controls. The tools in each of the categories of SQL provides the different types of information for the use and analyzing the quality of the product. Here what it does, it provides different types of information by which quality of the product can be analyzed. Okay, these tools measure the value of the quality characteristics. These tools are used to measure the quality characteristics. This also helps us in identifying a change or a relation in the quality characteristics of a product. Here it tells whether to what extent any changes are required in regarding the quality standard. Now, generally, these three techniques are used in the statistical quality control. First is what? Descriptive statistics. All of you know about the descriptive statistics. The statistics is used to describe the quality characteristics. Here we just describe the quality characteristics and its relationship. It involves measurements like example, mean, standard deviation, the range, and the distribution of data. Okay, then here we just describing the characteristics in the descriptive statistics. Okay, then we have acceptance sampling. Acceptance sampling is what? Here it refers to the process of randomly inspecting the sample of the goods and service goods and deciding that whether to accept the entire lot based on the results. Suppose we are an inspection is going on in an organization and they just selected a sample of goods and for an inspection. After inspection, they found that one or two unit there is a defect exists in one or two unit. Then what they will do, that they will reject the whole lot. Whole lot will be rejected. So this is done in the acceptance sampling technique. Okay, acceptance sampling is determine whether the batch of the goods should be accepted or rejected. It determines that whether the whole lot or the batch should be accepted or determined. If any defects is detected, then the whole lot will be rejected, or if everything is fine, the whole lot will be accepted for dispatch. Then we have statistical process control, means SPC. Statistical process control. It is the statistical tool that involves inspecting a random sample of the output from the process and deciding whether the process is producing the products with the characteristics that fall within the predetermined range or not. Okay, here what statistical process control. Here it is related to the process that whether the manufacturing process through which the output is being coming out, we check that whether these products are produced according to the whether the characteristics exist in the process which is predetermined from the organization side, it exists or not. Okay, then SPC answers the question of whether the process is functioning properly or not. SPC is all about, means the statistical process control deals with all the processes through which the whole manufacturing process, manufacturing of unit is done. Whenever any study of regarding the process will be done, it will come under the statistical process control. Okay, in descriptive, you are just describing the characteristics and the certain measures of central tendency or dispersons are used. Acceptance sampling, you are inspecting randomly a sample, and if you find any defect, you will reject the whole sample. And in statistical process control, you are just analyzing checking, monitoring the process through which the whole manufacturing activity is done. Okay. And you try to examine that whether the process is according to the predetermined standard or not. I hope now it is clear. Now we have next concept of total quality management is the Kaizen. Kaizen is a Japanese good change. Japanese for good change. Okay, it was introduced in Japan. It is has been applied in healthcare, psychotherapy, life coaching, government, banking, and other industry. Okay, the Kaizen is the process of continuous improvement. Kaizen means what? KCI means Kaizen is a process of continuous improvement in small investment that makes the process more effective, efficient, and controllable controllable and adequate. Here we are trying to make a improvement at the continuous level, where we are doing what? We are making the process in a more effective, efficient, and controllable and adequate way. Okay, the improvements are usually accomplished at the little or no expense with the output sophisticated techniques or supervision equipments. Here what we are trying to do, we are usually improvement at the gradual, at this very small level, or no exposure with the sophisticated techniques. Here no complicated techniques are used, we are or neither expensive equipments will be used. Okay, it focuses on simplification by breaking down the complex process into sub processes and then improving them. Here what is done, the whole process is broken down in small parts, and they are improvement is done in very small place. Suppose this is the entire process. Here what you have done, this portion you have broken. This is A, then this is B, then this is C, then this is D. What you are do, this will, you will try to improve this gradually, then you will improve do some improvement in this sector, then improvement will be done here, improvement will be done in section C. Each step which is a part of that whole process will be improved at a gradual, continuous level. Here in the umbrella, under the umbrella of Kaizen, different things are covered, like customer orientation, how customer should be oriented, then the total quality control, Six Sigma, we are going to see this, then robotics. Nowadays robotics is most popular technique used in many organizations. Then quality circle is also uses Kaizen. Then suggested systems are used. Then in case of in field of automation, Kaizen is used. And discipline in the workplace, to maintain the discipline, Kaizen is used. Then the total productive maintenance is also a area where the Kaizen is used. Then Kanban, quality improvement, just in time means is an inventory management technique. Then we have zero defect, small group activities, corporate labor management relations. In labor management relations, here we are trying to, in all these sectors, we are trying to just improve our relation. We are do it in a better way. We want to do it in a better way, in a most effective way. So we are applying this Kaizen technique. Okay. Then productivity improvement and new product development. Suppose when you were started preparation for your Kaizen, here I am giving you a real life example. How does it work? That suppose when you started your preparation on the first day, you might have studied for the 1 hour only. 1 hour to dur ki baat ho gayi. You might have just studied for 15 minutes. You just check the syllabus, just studied what is there, what we have to study. Or on second day, the 15 minutes then extended to 30 minutes. You just watched a YouTube video. Then it slowly, gradually exceeds. And now when the exam is on head, you have an ability to study for 7 to 8 hours at least. Like I am giving my own example. When I started teaching, I used to upload a video of 1 minute, only 1 minute. Sorry, not 1 minute, only 10 minutes. I started from 10 minutes, and now I have such a potential that I can teach up to 2 to 2.5 hours continuously. Then we have 5 S in Kaizen. There are 5 S in Kaizen. This can be given in match the column. This can be asked. So you have to remember. Sirai is what? Sorting. Sirai na, Surai mein kya karte hain? Sort karte hain. Okay. सुराही में तो वैसे पानी भरते हैं, बट अब वी हैव टू रिमेंबर दैट सुराही में क्या करते हैं, सुराही में सॉर्टिंग करते हैं. ओके, देन वी हैव सीटॉन. सीटॉन इज व्हाट, शाइनिंग. सीटॉन लगाओगे तो शाइन करोगे, ठीक है, सीटॉन लगाओगे तो शाइन करोगे. Then we have seesaw. Seesaw, C in order, C in order, that we use seesaw. Seesaw here, what is done, we set it in order. One person sits at that side and one person this at that side. I am telling this इसलिए बता रहा हूं ताकि आपको याद रहे. Seesaw. Seesaw is what, set in order. A particular, we will set in a particular order. Then we have Siketsu. ये तो और भी अजीब नाम है. Sketso means what? Standardization. Means सिकित्सु है ना, सिकित्सु का क्या करना है, स्टैंडर्ड. सिकित्सु किस लिए यूज होता है, सिकित्सु का कोई स्टैंडर्ड नहीं है. ओके, सिकित्सु यू रिमेंबर, और यू जस्ट रिमेंबर साकेत्सु. साकेत्सु का कोई स्टैंडर्ड नहीं है. ओके, in this way you can remember. And then you have shitsuke. Shitsuke means sustain. Oh shit, मेरे को तो यहाँ sustain करना पड़ेगा, तो this is the way you can remember. Shit, अब sustain भी करना पड़ेगा. In this way you can remember this shitsuke. Okay, so I am repeating once again for you. सुराही में क्या करेंगे, sort करेंगे. Means सिराही is sort. Then siton is what, shine. Siton लगाओगे तो shine करोगे. Then we have seesaw. Seesaw means what, there seesaw is there, जहाँ पे आपको क्या करना है, set in a order में set करना है. Then we have seketsu. Seketsu, ketsu का क्या नहीं है, ketsu का कोई standard नहीं है, standardization. Then the last one is shitsuke. Shitsuke means what, oh shit, I have to sustain. This is the 5S of Kaizen. Then we have quality control, quality circles. We have seen Kaizen, and now we are studying the quality circles. Quality circle is what, a group of expert people will come together and they will study a problem, solve that problem and move away. Okay, a quality circle is a group of workforce members, usually from within the same work area or doing the similar work. A group of expert people within the same work area or who do the same work, who volunteers to meet weekly on a company time to address the quality problems that occur in the work area. Whatever the quality problems occurred in an area, they meet together on a volunteer. They meet as a volunteer and resolve the issues on a weekly basis. Okay, so this is, you are seeing the people, who is a group of people. कितने सुंदर बच्चे घूम रहे हैं, नहीं क्या? They have joined together on a voluntary basis to solve the issues related to quality. Okay, अरे भाई, इतने रंग बिरंगी कपड़े पहने हो, तुम खुद ही क्वालिटी वाले हो यार, तुम क्या क्वालिटी इंप्रूव करोगे? Jokes apart. So here the proper sequence is followed, that is plan, do, check, act. Okay, now here we have the PDCA cycle. PDCA cycle is the plan, do, check, act, or sometimes they give plan, do, check, react. Don't get confused. PDCA has this A has both the meanings, either act or either react. Okay, PDCA sometimes said as plan, do, check, adjust. Adjust is also there. Then is a repetitive. It is a repetitive 4-stage model for the continuous improvement CI in the business process management. In the business process management, you have to improve on the continuous basis. So here the 4-stage model, the PDCA means plans, do, check, act or adjust, is followed. Okay, the PDCA model is also known as the Denning circle or cycle. Will-Sheward cycle, control cycles, or plan, do, check, act cycle. Plan, do, study, act. Sorry. So it was given by Dr. William Edward Denning, who is called as father of quality management, and John Stewart. Okay. Then the model is implemented to improve the quality and effectiveness of the processes with the product life cycle management. With the product life cycle, we want to improve the quality, so we use this PDCA cycle. Okay, here it is also used in project management, human resource management, supply chain management, and And other areas of business, here all the areas are mentioned where the PDCA cycle is used, either in case of supply chain management or product life cycle management or project management or HRM. We are using the PDCA cycle. It was given by William Edward Deming. Then here the proper sequence is there, what each step is what is done at each step. So in the planning step, what should be like define objectives and action planning. Here we define the objectives at the planning stage. At the do stage, what should we do and how should we do it is implementation. It is the stage, do is the stage of implementation. Okay, then the check stage. Check stage is what was achieved. What was achieved, we will check the achievement of objectives. Whether the objectives are achieved or not, we will check in the check stage. And in the act stage or the adjust stage, what is there, what else is there to be done, what else is there, what is the any backlog is pending, we will check this. And we will act according to identify room or implementation. Okay, what else is there to be done in the act stage? This can be asked in straight match the column type questions. So I have added in the questions were maintained will be mentioned in one side, and on the another side this plan, do, check, act will be there. You will have to match it. So this cycle is very much important. It's just simple and easy to remember. Then we have Six Sigma. Six Sigma is what? Six Sigma is a set of management tools and techniques designed to improve the capabilities of the business processes by reducing the likelihood of error. Okay, we are trying to improve the capability of the business process by reducing any chances of error. Okay, Six Sigma is a data-driven approach that uses the statistical methodology for eliminating the defects reduction, and profits improvement. Here, what is we are doing? We are using it includes a statistical method by which we can eliminate the defects, and the reduction in defects will lead to profit improvements. Okay, the etymology is based on the Greek symbol sigma. The etymology of this Six Sigma is based on the Greek symbol sigma, or is a statistical term for measurement process deviations. Here, whatever the process deviation are occurring, we are it is measured from the process mean or target. Okay, Six Sigma come from the bell curve used in the statistics. As we know that the normal distribution curve, same it is talking about the bell-shaped curve where we find the deviations. Okay, where the 1 sigma symbolizes the single standard deviation. 1 sigma symbolizes the single standard deviations from the mean. If the process has 6 sigma 3 or above or below the mean, that defect rate is classified extremely low. If the value of the sigma is 3 above 3 and it's above above 3 and below, and 3 and below, it will be said that it includes the defects are extremely low. Then we have the DMAX cycle. Earlier we see in the PDCA cycle. Now here we are doing the DMAX cycle. This is quite different. The main purpose of the DMAX tools is to improve the efficiency and effectiveness of the organization existing processes. Whatever the processes existing in the organization, the DMAX cycle is the DMAX model is used to increase its efficiency and effectiveness. Okay, DMAX is a Six Sigma's core data driven improvement methodology. DMAX is the entire methodology which is covered under the Six Sigma. Okay, when we improve the process and the problem is complex, when the problem is complex or we want to improve the process, the existing risks are high. At that time, the DMAC is the go-to method. Then at this stage, the go-to DMAC is the method which is used when the risk is high and the process is complex and we have to do the improvement in the process. Lean Six Sigma, here the DMAC cycle stages are defined. It's first of all, you have to remember its full form, that is define, measure, analyze, improve and control. Okay. Then in the define stage, you will define the problem. Then in the measure stage, you will quantify the problem. What is you will quantify in the measure stage, then you will analyze that, you will identify the cause of the problem. What are the reasons behind the occurrence of the problem? You will study at the analyze stage. Then in the last, in the improve stage, you will implement and verify the solution. Whatever solution you have decided, you will implement in the improve stage. And C, control stage, you will maintain the solution. Whatever the solution which you have implemented, you will try to maintain in the control stage. Okay. Then this is the last part. This belongs to operation research portion of the operations management. Here, let's distinguish the PERT and CPM, because a lot of times questions are asked from this concept. So PERT is what? That is project evaluation review technique. And CPM is what? CPM full form is the critical path method. Remember that PERT is an event oriented technique. PERT is the event oriented and it is CPM is the activity oriented. Okay. PERT manage the unpredictable activities, whatever and predictable activities which occur during the production period. PERT is used to manage. Okay, manage it. And CPM manages the predictable activities. Whatever the activities are predicted earlier, then we use the CPM to manage it. Okay. Then PERT focuses on the PERT is focused on the time control. It focuses on the time control, and CPM it focuses on the cost optimization. So that the at optimum cost the production should be done at large quantity. This is the in the CPM model, and in the PERT model we see that in least time our production can be done. It was developed in 1958. The PERT was developed in the 1958, and it was developed. CPM was developed in the 1957. Okay, then. The second last point is it is a 3-time estimate. PERT is a 3-time estimate and the CPM is a single time estimate. Okay, then it is the probability model. In case of PERT, a probability model exists, and in case of CPM is a deterministic model which is give you the which will determine the accurate time. Okay, sorry, accurate cost. I hope this model, both the models are clear here. That's all about the operations management. We have covered all the important topics. I hope you have understood all the topics of both the statistics and operation management in this crash course. Thank you. Bye.